All right, so this is going to be part 2 of screencast for 12.1. So let's look at special triangles. So in your geometry class last year, you talked about these special triangles. There's really 2 of them that we care about that we're going to be using all the freaking time. So an isosceles triangle, wait, what's isosceles mean? Two sides are the same. So that would mean 2 angles are the same. 45, 45, 90. That's one special triangle. The second special triangle is a 30, 60, 90. One of the angles 30, one's 60, the other's 90. So these are the 2 triangles where you will have to know the trig values for them. So what I mean is you should know what sine, cosine, and tangent are for the 45, 45, 90 and 30, 60, 90 triangle. So let's go ahead and let's find out the relationship between all 30, 60, 90 triangles first. So I gave you the triangle. So I see my 30 degrees, my 60 degrees, my 90 degrees. How would I actually, how would we solve for this before? How have we been solving for triangles? Exactly. Find the missing side. What is 12? Here, 12 is my, let's shoot. I have to pick an angle first. Let's have 30 degrees be my angle. How would I go about solving for sine, cosine, tangent? Good. So 6 would be my opposite side. 12 is my hypotenuse. So I can do the sine one, right? Because SOHCAHTOA, sine is opposite over hypotenuse. So 6 over 12, wait, that's going to be 1/2. Okay, cool. But cosine, I need the adjacent side. How do I solve for the adjacent side? Minus 36 on both sides. I have 108 equals b squared. So I'm just doing Pythagorean theorem, solving for the missing side length. I'm not going to use decimals. I'm going to use radicals and be exact. Let me zoom in on this just a tad. So let's see, square root 108. Well, it would be nice to know the factors of 108, and let's see if there's a perfect square in there. So 4 and 27, okay, 4 and 27, and then the factors of 27? 9 and 3? So I'm going to pause there, I'll pause here, and I'm going to rewrite square root 108 as the same thing as square root 4 times square root 9 times square root 3. Because I have 4 times 9 times 3 is 108. So 2 times 3 times root 3 is just 6 root 3. And this is going to be my adjacent side if I'm talking about the 30-degree angle. Awesome, 6 root 3. So there's a special relationship in triangles. I'm going to tell you now. So across from your 30-degree angle is going to be 1/2. Across from your 60-degree angle is going to be root 3 times whatever your short side is. Maybe I should revise this and make it general. Across from 30 degrees is going to be your short side, and I'm going to label that length x. Across from the 60 is your longer the short sides. It's going to be root 3 times whatever your short side was. And your hypotenuse is going to be 2 times your short side. So if you go back in your notes from last year, you covered this special triangle. Literally, the cross from 30 degrees, the side length, I'm going to label x. It's just, it could be 1, it could be 1/2, it could be 3. Whatever the short side is, all the rest of the sides are related in the sense that the hypotenuse is 2 times the shortest leg, and across from 60 degrees is root 3 times the shortest leg. Let's see if that's true. Here, my shortest leg is 6, meaning x would be 6. So if I plugged in 6 into x, I had root 3 times 6, and that's exactly what I have here. 2 times 6 is 12. Hypotenuse is 12. Little secret action going on for you. Okay, so we'll double check that this is right on the next 30, 60, 90 triangle, but this is a little spoiler alert. Okay, so we have our hypotenuse, opposite, adjacent, labeled. Let's go through, let's find out what cosine is. What would cosine of 30 degrees be? Yep, it's adjacent over hypotenuse. So 6 root 3 over 12. How do I simplify this? Yeah, root 3 over 2. How did I go from like here to there? Yeah, exactly. I simplified 6 and 12. And lastly, tangent of 30. TOA. Opposite over adjacent. 6 over 6 root 3. So if I simplify this, I have 1 over root 3, but that's not going to fly. What do we need to do? Root 3 over 3. Cool. Exactly. Let's go through, and instead of having 30 degrees be my angle, let's have 60. So now, oh, JK, 12 is still going to be my hypotenuse. That doesn't change. But instead, 6 is now my adjacent side. 6 root 3 is now my opposite side. So if I'm wanting to do sine of 60, that's going to be equal to, let's see, sine is opposite over hypotenuse. Here, my opposite is 6 root 3 over hypotenuse 12. I can simplify this to be root 3 over 2. How would I figure out my cosine, Noah? Cool. So adjacent, 6, hypotenuse 12. Can simplify that to a half. Oh, check out what's happening. Because what used to be my opposite side is now my adjacent side, right? So this happens in triangles. Don't worry if you're not seeing it, but you can kind of see there's a pattern. Well, not quite. It's going to be... And so the whole reason is because here, what used to be my opposite side, what used to be my adjacent side is now my opposite side. So cosine of 30 and sine of 60 were the same. But you'll see this pattern. Lastly, tangent of 60 degrees. So tangent is opposite over adjacent. So I'm looking in my like maroon reddish color, because according to 60 degrees, the opposite side is 6 root 3 over adjacent. Well, adjacent here is 6. So simplifying, it's just going to be root 3. So tangent of 30 was 1 over root 3. Tangent of 60 is root 3 over 1. So it's like flipped.
If we've done the 30 degrees, do we have to do it for the 60 degrees?
Well, so this is a little exploration, and you're going to see that there's a pattern. Like, I wouldn't give you this long of a problem. It's not really useful. I'll literally ask you sine of 30. And I'll probably have a non-calculator portion. All right, let's go through and let's solve for this. So once again, we have a 30, 60, 90 triangle. So 30, 60, 90 triangle, let's come up to our special triangle. So the hypotenuse is 2 times the shortest side. What is my hypotenuse in this second example? 15. Okay, so if 15 is my hypotenuse, 15 equals 2 times my shortest side. What should my shortest side length be? We do. 15 over 2 is my shortest side. So this is my hypotenuse. And I was talking about the special triangle. When I have a 30, 60, 90 triangle, the side opposite of 30 is your shortest side. And if that is x units long, I can talk about the other legs, other sides in relation to that. The hypotenuse is 2 times the short side. So wait, if 15 is my hypotenuse, which one's my short side? The shortest side is the one opposite from 30. So I wanted to know, what is this length right here? Half of the hypotenuse, which is 15.
Why is it half the hypotenuse?
So across from 30 degrees is your shortest side. Across from 30 degrees is your shortest side. The hypotenuse is 2 times your short side. 15 is 2 times my short side. Since 15 is 2 times my shortest side, to find out what would be, I divide both by 2. So 15 over 2 is my shortest side. And let's make sure this is, like, this whole special triangle is true. So across from 60 is going to be root 3 times your short side. So here, since my short side is 15 over 2, I should just multiply by root 3, and that should be the side opposite from 60, which it is.
Oh, isn't there that thing, remember something in geometry last year, it's like x root 3 over,
Yep.
then it's like 2x.
That's exactly what it is. Special triangles. Okay, so this kind of looks messy. Do you want me to leave this here or like erase it so it looks cleaner? I just don't want to confuse you guys. I want to like be as straightforward as possible. Just leave it. Okay. Let's go through and let's solve for my stuff. Okay. First, I'm going to use 30 degrees. So according to 30, this is my adjacent side, this is my opposite side, and this is my hypotenuse. Okay. So if I want sine of 30, let's see how fast we can go through this. Sine of 30, Hallie, walk me through how to do this one. Wait, what? I thought it was over hypotenuse. Yeah. Okay. So 15 over 2 divided by 15 is the same thing as 15 over 2 times the reciprocal, 1 over 15. What happens to the 15? Cancels out, so it's just 1/2. It looks like an A. I'm sorry. A little sloppy, I'm sorry. Cosine is adjacent over hypotenuse. So 15 root 3 over 2 all over 15. So if I'm taking 15 root 3 over 2 divided by 15, it's the same thing as if I would do 15 root 3 over 2 times 1 over 15. Dividing is the same thing as multiplying by the reciprocal. So guess what happens to 15? Cancels out. So this is just going to be root 3 over 2. Tangent is opposite over adjacent. Opposite over adjacent. So I have 15 over 2 over 15 root 3 over 2. So I want you to notice it's like 15 over 2 divided by 15 over 2. It's going to cancel out and be 1 over root 3. Which then we have to rewrite as root 3 over, oops. Oh my god. To rewrite as root 3 over 3. Oh. So I'll show you how to do that. 15 over 2 divided by 15 root 3 over 2. Same thing as 15 over 2 times 2 over 15 root 3. This cancels, that cancels. 1 over root 3. Okay, let's take a second. What do you notice from, this line and this line?
So for every 30, 60, 90, is it going to be?
Every 30, 60, 90 triangle, no matter how big it is, the ratios of the side are the same. Whenever you take sine of 30 degrees, it will always be 1/2. It's always 1/2. That's it. When you take cosine of 30, it will always be square root 3 over 2. That's it. Doesn't matter if you have a puny little triangle or a triangle the size of the United States, as long as it's the 30, 60, 90 triangle, the ratios of the side lengths will be the same. Like how they compare to each other will be the same.
Does that transfer over to like every triangle, not those numbers?
As long as the triangles that have the same angles.
Oh, okay.
Yep. So, okay, can we guess what sine of 60 should be?
Root 3 over 2.
Root 3 over 2. What should cosine 60 be?
1 over 2.
And tangent 60? Alright, let's check if we're right. Let's check if we're right. So sine of 60 degrees. Okay, so we'll go back. Erase these colors. Let's see. According to 60 degrees, this is my adjacent side. This is still my hypotenuse, but now this is the opposite side because it's according to 60 degrees. So sine is opposite over hypotenuse. If I take 15 root 3 over 2 and divide by the hypotenuse of 15, it will be just 3 over 2. So I'm proving that to you right now. Oh my god, this is amazing. Check that out. Once you figure out the ratios, you don't even have to show work. You don't have to do math. You have it in your brain. There you go. Cosine 60 should be 1/2. Okay, so this is adjacent, 15 over 2, right? Because that's my adjacent side, over hypotenuse. So dividing by 15, hypotenuse. Dividing by 15 is the same as multiplying by a reciprocal, 1 over 15. It's 1/2. Okay, proven? Proven. We're good. So that's pretty cool. Now let's find the values of the trig functions of 45, 45. So, I think I'll give you the sneak preview of this special triangle. So when you have a 45, 45, 90 triangle, you have leg, leg, root 2 times leg. It's pretty easy to remember. Leg, leg, hypotenuse is going to be root 2 times whatever your leg is. Okay, so check it out. So that means hypotenuse here is 7 root 2, meaning each one of my legs are 7. Does it matter which 45 I choose?
No.
No, it's going to be the same. It'll give me the same, which is why I only give you one line. So let's pick this one, whatever. Here's my adjacent side. Here's my opposite side. Sine of 45. Okay. So I need opposite over hypotenuse. Opposite, 7, over hypotenuse, 7 root 2. So when I simplify this, I have 1 over root 2. How do I rationalize this? multiply by root 2 over root 2. So root 2 over 2. Now if I do cosine, oh my god, now I need the adjacent. Okay, adjacent over hypotenuse. So 7 over 7 root 2. Oh my god, it's the same thing because it's the same number. Because my opposite and adjacent sides are the same number, cosine and sine match. They both are root 2 over 2. And if I do tangent, which is opposite over adjacent, it's going to be 1. Oh my god, that's so chill. Okay. So in this next page, it like tells you all of this. This is exactly what I was showing you. Leg root 2. X, root 3 times x, 2x. So this is like the summary of how we do this. And it gives you all of the values of the ratios rationalized. So it's like quick, dirty, fast summary right there so you can use it. Get used to it. Okay. Need more time to write this down? No. Alright, let's go through example 4. We can do this. Calculate the height of the building to the nearest whole foot. Okay, so what I have this side length, I have this angle, and I'm wanting this side length. So this is where we're actually going to start applying trig ratios. So I have my angle is 76 degrees. Okay, so 200 feet, which side is this? Is this the hypotenuse? Adjacent, opposite?
Adjacent.
It's adjacent. And I'm trying to solve for the height of the building. The height of the building here is the opposite. Okay, so I want to solve for opposite side. I have the adjacent side and I have the angle. Which trig function should I use to solve for opposite? Say it louder. Tangent. So I know that tangent of 76 degrees would be the opposite side, d, over adjacent, 200. How do I get d by itself? Multiply both sides by 200. So if you put in 200 times tangent of 76 degrees, you'll find the height. Make sure you're in degree mode. Make sure you're in degree mode. Do you want me to show you how to insert this on your calculator? Are we okay?
We'll be okay until...
I'm sorry, I cannot hear you. Oh. Do you want me to show you how to insert it, or are we okay? Alright, so we know that tangent of an angle is opposite over adjacent. So that's how we knew that tangent would be the right one here. I find that the distance is 802.156. So I can put 802.156 feet, right? That's all I put?
I'm assuming it's no. But I would say yes.
What's it saying? Nearest whole foot. So what's the nearest whole foot? So it's going to be 802 feet. You need to make sure you read directions and round to the correct decimal. Hey, that's it. There you go. That's your first problem applying trig, theoretically. How do you feel about that? Alright, so we don't have too much more to do. Yeah, so we'll finish. It's more just like trying out these triangles. So we'll solve the rest when I see you guys tomorrow in class, and then yeah, we'll finish solving tomorrow in class, and then we'll work on more problems from homework.